Okay, so we're going to go through this review packet, so I will make sure that there's a PDF of this, and feel free to skip around, not watch the whole thing. But if you need help with going through some of these problems, this is designed for you. First two questions have to do with writing the equation of a line, and we want to write this in slope-intercept form, which of course is y equals mx plus b. So what we need to do is, if we're given a point and another line, we need to use point-slope form. Now the important thing is this parallel. What we're going to do is we're going to take the slope of this line. So this slope here is 2. So that means that our line that's going to be parallel is also going to have the same slope. Parallel lines have the same slope. So what we do is we use point slope form, which is y minus y1 equals m times x minus x1. And we have our point, which is 2, 1. So that means the y value is 1. I have my slope is 2, and the x value is 2. So from here, all I need to do is just isolate the y, and I'm actually going to turn this into slope-intercept form. So I get y minus 1 is equal to 2x minus 4. If I add the 1 to both sides, I get y is equal to 2x minus 3. And that is the answer there. For the second one, I want to do a similar approach, except this slope is perpendicular. So that means the slope is going to be the opposite reciprocal. If the original slope is negative 1/3, then the opposite will be positive, and the reciprocal will be 3 over 1. So this new slope will be 3. So again, using point slope form, which I can write out, the point is 3, 6. So I get y minus 6 is equal to 3 times x minus 3. Whoops, I don't know what happened there. X minus 3. And we distribute and solve for y. So y minus 6 is equal to 3x minus 9. If we add the 6 to both sides, I get y is equal to 3x minus 3. And that is my answer there. So for this one, we have actually the same y-intercept as before. Be careful of that. That's not always the case. So don't just look and say, oh, the y-intercept's negative 3. That's going to be the case for all of them, because it's not. If you look at the first one, the y-intercept is negative 3/2, and this is not negative 3/2. So be mindful of that. For 3 and 4, we're just evaluating, which means we're plugging these values in. So if f of x is 3x minus 5, f of 2, we replace the x with a 2. So this is 3 times 2 minus 5. So that means that f of 2 is equal to 1. Here, f of negative 4 means that we're going to have 3 times negative 4 minus 5, which is going to give us negative 12 minus 5. So f of negative 4 is equal to negative 17. Really straightforward there. Just substitute the values in. Now we have a piecewise function. We have to determine which line we're going to use. So notice the piecewise function has 5 minus 2x when x is less than 0, and all other times, so when x is greater than or equal to 0, I'm going to use 4x plus 5. So here, negative 1. X is negative 1. Do I use the first line or the second line? I'm going to use the first line because negative 1 is less than 0. So I do 5 minus 2 times negative 1, which is the same as 5 plus 2. So f of negative 1 is equal to 7. That's it. I had some people on the quiz plug it into both. You should not get 2 answers for this. It's a one or the other type deal. Now f of 0, since 0 is greater than or equal to 0, I use the second line. So this will be 4 times 0 plus 5, which is just 5. So f of 0 is equal to 5. Be careful not to plug this into both. Just use one or the other. So take note of that and get some more practice. Let me know if you need some more problems. A function has Well, if you think about a vertical line test, a function cannot include a vertical line. So here, if I draw a vertical line through it, that's not a function. And the reason is this vertical line is an x value, which is an input. This input gives us two different outputs. That can't be the case. Now, if we have just a normal parabola, if I have this horizontal line, that's a y value, I have one output for two different inputs. That's okay. This is not. So know the difference between not being a function and a function. Here, this is a parabola. It's x squared. So I can solve for y here. And if I solve for y, I'm going to get y is equal to 2x squared minus 10. And so this is a function, yes. But over here, if I solve for y, so if I isolate y, I'm going to have 6y squared is equal to 3x plus 12. Divide both sides by 6. Get rid of this mess. I'm going to have y squared is equal to 1/2 x plus 2. And I have to take the square root. Now, when I take the square root, it doesn't specify whether we want a positive root or negative root. So I have to take both whenever I solve. And because here, if x is 0, I get the positive square root of 2, the negative square root of 2. That's two different y values for one x value. That's two outputs for one input. So no, this is not a function. Number 9, that's just a horizontal line, and that's fine. Number 10, this is actually a circle. So this is a circle with the radius 3. But you don't need to know that. Again, you can see that y. And just know, no, that is not a function. So, pay attention to when you have a y squared. That's really the telling sign. If you have that y squared, means when you isolate y, you're going to have a plus or minus, which is not a function. All right, so here we want to find the relative maximum, relative minimum, intervals of decreasing and increasing, and all that good stuff. So here, the first one. If I have the maximum, relative maximum for part A, the relative max is a turning point. So we can see that we're changing directions at this point 2, 4. There is no relative minimum, and that is okay. The interval for where it's increasing, well, I can see I'm going up and up and up. Increasing only refers to the x values, so know that it only refers to the x values. So we're increasing starting at x is negative infinity, going up all the way to 2. And then for where we are decreasing, if you look again at that turning point there, x is 2, we're going from 2 to infinity. Notice the x value for that turning point separates our increasing and decreasing intervals. And increasing, decreasing intervals always have parentheses because at that turning point, I'm neither increasing nor decreasing. I'm stagnant, I'm stationary. All right, so for the second one here, the relative max, again, a turning point, we can see it's at negative 2, 3. And the relative minimum, where we are, again, turning around, is at x is 0 and y is 2. So understand that we're not talking about absolute value or absolute maximum, absolute minimum. These are just relative, so great way to think about them is just these turning points. So increasing, where are we increasing? Well, if we look, the relative minimum is 0 and the relative maximum is negative 2. So chances are that these values will appear in this interval. And so where am I increasing? Where am I going up? Starting when x is negative infinity, and I'm going to x is negative 2. Then I start decreasing, but then I start increasing again at 0, and I go increasing all the way to infinity. I'm decreasing between that -2 to 0. So notice this jump, -2 to 0. All along this function, I'm either increasing or decreasing. This is very nice. These values, -2, 0, they pop up because those are the x values of our turning points. So understand how we get those intervals. That increasing, decreasing intervals are always put into parentheses. And there are lots of other examples that we did. So if you do need help with them, look over those examples. I believe that was it on that page. Yeah. Oh, E, what is the domain of the function? For both of these, there is no break. So the domain for both of them is just negative infinity to positive infinity. I believe I used to talk about the range on these, which we're not going to talk about. So domain's just positive infinity, negative infinity, positive infinity. All right, so here, transformations. I actually give you the function, and then we have to figure out what the new graph is going to look like. So I'll do this in green. The graph here is the parent function, it's a parabola. And I have these 5 points. So I want to know what these transformations are. Well, there are 2 of them. I'm going to shift to the right 4, then I'm also going to shift down 5. So for each point, I'm going to shift to the right 4. So this one's off the charts. This one here, if I shift to, oh, sorry, it's not. 1, 2, 3, 4. And then I'm going to go down 5. So notice at this point here, shifts to there. This one, if I go to the right 4, 1, 2, 3, 4, then it goes down 5. 1, 2, 3, 4, 5. This point here, shift to the right 4, 1, 2, 3, 4, down 5. This point here, to the right 4, and then down 5. And then actually this is the one that will be off. So if I graph this, do my best to connect the dots, there's my new parabola. So just imagine we took this and just shifted it down to those spots. It would overlay perfectly. All right, and so for the next one, we have an absolute value function. Again, they give us the parent function, which is nice. And there are 3 transformations. So the first is that this shift here, or this flip, we are flipping along the x-axis. We are shifting right 3, and we are shifting up 2. So for these points, I can shift to the right 3, so 1, 2, 3, go up 2, 1, 2, and here my y value is at positive 4. So at 1, 4 means now I'm at negative 1. Sorry, positive 1, negative 4. So 1, negative 2. Actually, you know what? Sorry, we should flip it first. So here, if I start at negative 2, 2, and I flip this, so now I'm at negative 2, and then I go up 2 to the right 3. If I plug in 1, I will get 0. So now I'm at this point here, and I flip this. Then I move to the right 3, so 1, 2, 3. And then I go up 2. There we go. I'm at my vertex. So I flip it. It's on the x-axis, so I can't move. To the right 3, 1, 2, 3, and then up 2. Then over here, I flip it, so now I'm at -1, to the right 3, 1, 2, 3, and then I go up 2, 1, 2, and finally this one is at +2 for y. I flip it to be -2, move to the right 3, and then go up 2. So when I graph this now, I will have, make this straight, little cheat. We'll have that. And that's our graph. So that's our flip, our shift. So make sure you're comfortable with this. This is tricky because you had to do the shift first. If you're ever not sure about if this is a correct point, take this point and plug it into your original function. So here, if I plug in x is 3, I get 3 minus 3, which is 0. So -0 plus 2, so +2. That's a correct point. So we can check our answer by plugging it into the function. All right, so here we got some transformations. This is just like the quiz, where all we had to do is write down what the transformations are. So the first one, we can see that we have this 1/3, so we are going to shrink or condense by a factor of, well, a third or 3. We're taking these y values and we're multiplying by a third or dividing by 3. Number 14, this is going to be a flip on the y-axis, sorry, the x-axis. Say it's the x-axis because this is in front of the parent function, front of the absolute value. And then we are going to shift to the right 6. Next one here, we are shifting to the right 3. And we are going to shift up 2. This one, it may look like a -2, but break this up into 2. So that negative, again, that negative means we're going to flip along the x-axis. And then that 2 means that we are going to stretch by a factor of 2. So make sure you realize it's not a -2, it's a negative and then a 2. It's 2 different pieces as opposed to one value for -2. Okay, so that's there. So why don't we move on to the next page? Well, we got some more. Fantastic. Let's do these. Here, this is a -x. Technically, I won't be too fussy. This could be a flip on the x-axis or the y-axis. I'm going to write the y-axis, but technically that could also be the x-axis. And then we shift up 3. Here, a whole bunch of stuff. So we are going to shrink by 1/3. We are going to shift left 2. And we are going to shift down 4. All right, f minus g of x, these are combinations, so we're adding and subtracting. So f is 3x squared minus 4x plus 2, and we are subtracting g, which is -x squared minus 4x. Notice how I wrote these in parentheses. That's key because these distribute in. So I get 3x squared minus a -x squared. That's 4x squared. And then -4x minus a -4x is going to be 0x. So that's just 0x. And then 2. There is no like term over there, so I just get 4x squared plus 2. All right, the next one here, g minus f of x. So I give myself some space. B, g minus f of x, that's going to be -x squared minus 4x minus f, which is 3x squared minus 4x plus 2. We have a -x squared minus 3x squared. That gives us -4x squared. -4x minus the -4x, again, is 0. And then 0, or nothing, minus 2, which is to -2. So notice how they're opposites of one another. Interesting. And finally, we're adding them together. So we have f, which is 3x squared minus 4x plus 2 plus negative x squared minus 4x. We're adding. So 3x squared plus negative x squared is 2x squared. Negative 4x plus negative 4x is negative 8x. And then 2 plus nothing is 2. Now that changes when we talk about here, and we're multiplying. So f times g of x, this is f g of x, this is f times g of x. This is x minus 5 times x squared. So we multiply these, we get x to the third minus 5x squared, and we're done. The second one here, f of g of x, we start with our f function, which is x minus 5, and we replace the x with the g function. So this is actually just x squared minus 5. We can't reduce that. C is g of f of x, so I start with the g function, which is x squared, and in place of the x, I replace x minus 5. So I multiply this all out, I get x squared minus 10x plus 25. When you're doing a composition of a function, always multiply it out. Don't factor, because if you factor, you're actually going to get back to just the first step of the composition, which is not helpful. All right, and then finally we have these inverses. So if we want to find the inverse function, first we switch the x and the y. So we get x is equal to 3y plus 7, and then isolate the y. So this will be x minus 7 is equal to 3y. So I get inverse of y is equal to x minus 7 over 3. I could do 1/3 x minus 7/3, but I just wanted to isolate the y, and so that's all I got there. All right, number 22, same strategy. X is equal to y minus 2 over 8. So I get the y by itself, multiply both sides by 8, so I get 8x is equal to y minus 2. And so the inverse of y is equal to 8x plus 2. That's it. Make sure you first switch the x and the y, then solve for y. Don't forget this little -1 to tell me that's the inverse. That is important. And then to verify, we just need to show that f of g of x and g of f of x are equal to x. So for this first one, f of g of x should equal x. So if I take the f function, which is x minus 7 over 2, over 4. So x minus 7 over 4. And in place of the x, I put g of x. So that's 4x plus 7. The 7's cancel out, so I get 4x over 4. And of course, this does equal x. If I wanted to show g of f of x is equal to x, g of x is 4x plus 7. And then in place of the f of x, I get x minus 7 over 4. When I multiply, the 4's cancel out. So I just end up with x minus 7 plus 7, which of course is equal to x. Because they both equal x, I get the verification there. 24, same deal. I want to start with f of g of x and show that that equals to x. So the f function is 1/2 x minus 7, and the g of x is x plus 7 over 2. This is a mistake. That should be a 2. So, sorry about that. Because now when I multiply this across, I get x plus 7. Is this the same exact problem? It's like the same exact problem, except with 2 instead of 4. So, I don't know. We did plenty of these problems in class, so definitely take a look there for some of them. But again, for g of f of x, we get the x plus 7 over 2. We plug in 2x minus 7. The 7's cancel out, so we get 2x over 2, which is just x. That was a typo. My apologies there. But as long as you're good with the compositions of function, know that when you verify, they should both equal x. If they don't, then it means that they're not inverses of each other. So actually, if you had done this with the way it was originally written, these would not be inverses of each other, which is fine. We just say they're not inverses of each other. All right, here, domain, what can x be? This is a straight line, so I can plug anything in for x, negative infinity, positive infinity. Done. When you see a square root, remember, you can't take a square root of a negative number. So anything underneath the square root, in this case x minus 5, must be greater than or equal to 0. So x must be greater than or equal to 5. Well, how do we write this in interval notation? We start with 5, and we get a bracket because it could equal 5. And then we go all the way to infinity. X is greater than or equal to 5. With a fraction, fractions can not have 0 in the denominator. So x plus 3 cannot equal 0. So x cannot equal negative 3. So what's the smallest value that x can be? Negative infinity, of course. And it's fine. There's no problems until we get to negative 3. And it can equal everything up to negative 3. So it gets this parenthesis, and then immediately after negative 3, we start again, and we're okay forever. So our domain is negative infinity to negative 3, and then negative 3 to infinity. You can put that u there or not. It doesn't really matter. But understand fraction, square root, and when you don't have them. These are the main ones we will cover in class for domain. So understand them. Yeah, and so look over these questions and anything on your quizzes that you may have missed. And if you can do all those and the questions on the quiz, you are set for the test.